Hi, my name is Drew Griggs, and I'm applying to be a Chem peer mentor for the fall semester. I took Chem 102 in the spring of 2018. I placed out of 101, so I'm a little more familiar with the 102 curriculum, but I'm glad to help with either. I'm a rising sophomore, and I'm from a small town called Henderson, North Carolina. I want to be a peer mentor because I excelled in 102 here, and I want to, gain, knowledge with teaching and associate myself with teachers, and also help the incoming freshmen and sophomores, with their Chem 102 or 101. So, problem reads as find the pH in the titration of 25 milliliters of 0.3 molar hydrofluoric acid with 0.2 molar sodium hydroxide at the equivalence point. So we know we have 7.5 millimoles of hydrofluoric acid to start. We get that from multiplying 25 milliliters times 0.3 molar, which of course gives us 7.5 millimoles. So when we're adding this sodium hydroxide, at the equivalence point, we know that the moles of acid are equal to moles of base. So using this 7.5 millimoles, we can find the volume of our 0.2 m sodium hydroxide, which is 37.5 milliliters. So we know here that at this equivalence point, we have the same amount of millimoles added. And since we have the same amount of the two reactants, they're both in this reaction, there is 1 mole of each. There is no excess of sodium hydroxide or hydrofluoric acid. If there was some excess of either of those two, if there was an excess of hydrofluoric, we could see a buffer. And if there was an excess of sodium hydroxide, the base would just shoot up because we would just have this sodium hydroxide reacting with water, dissociating straight into OH ions. So, but since we're the equivalence point, it's a little different. We have 7.5 millimoles of water and NaF. Our concentration of this fluoride ion, we can assume it dissociates all to F minus, is going to be 7.5 millimoles divided by 62.5 milliliters. And this comes from the total volume of the solution we have, which comes from the 25 milliliters of hydrofluoric acid along with the 37.5 added of NaOH. This comes out to be 0.12 molar. So now we just have a weak base problem. We were given the acid dissociation constant, but now we can find the base dissociation constant based on that. Or 6.6 times 10 to the negative 4, which gives us 1.52 times 10 to the negative 10 for our Kb. So now using the equilibrium expression, OH minus times HF divided by our F minus to start is equal to Kb. Just plug our variables in here and here. And that gives us an OH concentration, 4.27 times 10 to the negative 6 molar. And we know the negative log of that will give us POH, but the problem asks for pH. So we can use the fact that we know 14 minus POH is going to be equal to pH. So 14 minus the negative log of our OH concentration will give us our pH, which comes out to be 8.63.